Okay, so in this problem here we have a pair of cylinders, logs I guess were said, that are sitting in this box, and they're frictionless, so we got to find the normal forces on them at each of the points where they touch the box. So that's here, and here, and here. And I'm just going to label them 1, 2, and 3 so that I can talk about them and know what I'm talking about. So the radius of the logs is little r, and we're also told that the width of the box is little r. So what this tells us then is that if we basically mark off the box here like this, and we draw like a little dotted line down there, then the width of the box is 3r, the radius of the box is r. So this distance here is r, right, between this, and this distance here is r, because here's the radius of this log, right? So, oh, that's not 3, it's r. Okay, sorry. R3, not the same thing at all. Okay, so then finally the distance between those 2 points, or the horizontal separation of the centers, has to be r. Now the distance between these 2 centers has to be 2r, right? So what this tells us now is this is 2r, what I've drawn in here, and this over here, which is the same as this, is r. So what this tells us is we have a 30, 60, 90 triangle in here. Okay, so now that lets us get the directions of the normal force between the two, and that will let us solve the whole thing. So I'm going to do now, I'll keep going in blue, I'm going to do an FBD for the top log, okay? So the top log. So what are the forces acting on this guy here? Well, to start with, we have mg, its weight. Okay, there's no tension because there's nothing acting on it, or there are no ropes tied to it. And we're told there's no friction, so that's out. So all we got is normal forces. We got this normal force from the wall, okay, which I'm going to call N1 there. And then we also have this normal force here from the bottom one. And just so I have a different way to refer to that, I'm just going to call that 4, okay? So N4 goes like that, and this angle here is 30 degrees, okay? So now we know everything we need to know for that. So we can, hi, I'm making a video. So let's go x, y there. And of course these logs are not accelerating, right? So ax equals 0, ay equals 0, and we're all happy. So components now, the top one, there's mg going down. We have, my wife just got home, that's who I was talking to, by the way. I wasn't telling you that I'm making a video, because you know. Okay, so this guy here splits into 2 components. This part is horizontal, and since this is 30 degrees, we know this is n4 times the sine of 1/2, or sorry, the sine of 30 degrees, which is 1/2. Okay, so 1/2 n4, and this vertical one then is root 3 over 2 n4. So I'm going to do my equations over here. Sum of forces is ma, right? Sum of forces in the x direction is max, and since that's 0, what we have is 1/2 n4 minus n1 has to equal 0, and then sum of forces in the y direction has to equal may, and then of course what that means is we've got root 3 over 2 n4 has minus mg has to equal 0. So that immediately tells us, well, I don't know where I want to do this. So let's see. That immediately tells us that n4 is 2 over root 3 times mg, right? Because it makes sense if you think about it. The only 2 vertical forces are the weight and this component of n4. So that tells us immediately what n4 has to be. And then, so that's one thing we sort of solved there. That wasn't part of what was asked for, but that's crucial to the rest of it. And then to find n1, we have that 1/2 of n4 has to equal n1. So n1 has to equal 1/2 of n4 from this equation, right? Which then means n1 just has to equal 1 over root 3 times mg. Okay, so that then is one of our 3 asked for answers. Now we got to do an FBD for the bottom log. I think I'll switch to purple, just for no particular reason. So FBD bottom log. Okay, And now forces on the bottom log go, well, of course, there's gravity going down. And then you have a normal force from 2 from here, right, pushing inward that way. Okay, you have a normal force on the bottom, that's N3. And then, of course, you have 4 pushing down here. So remember, this is the Newton's third law reaction. We had a force on the top log pushing that way, which means we have a force on the bottom log pushing that way. And it's the same, so it's got that magnitude N4 there. Okay, so, of course, doing our coordinates like that. And we also have AX equals 0, AY equals 0. Okay, so let's do components for the bottom log now. And we've got N3 going up, we've got N2 going to the right, we've got mg going down, and then we have N4 getting split 2 ways. So let's see, this is 30 degrees there, so this is 1/2 N4. Okay, and then make it bigger. So remember, if you can't fit all your arrows, all your force arrows into one dot, into the dot, make the dot bigger. So the downward component of N4 is going to be √3/2 N4. I'm doing this because I know 30, 60, 90, so I've got sort of neat, you know, well-known neat trig angles there. Okay, so what this gets us now is, so sum of forces equals MA, and then of course sum of forces in the x direction equals MAX. And that gets us to here, we've got N2 to the right, and then we have 1/2 M4 to the left. So 1/2 M4 equals 0, which means then, of course, N2 equals 1/2 N4, which is, well, let me just come out here and write N2 equals 1/√3 times mg. Okay, and notice that's the same as N1, and that kind of makes sense if you think about it. So if you think about the two logs of the system, then the external forces on the system, you know, the horizontal external forces anyway, are N1 here, right? And N2 there, right? Nothing else is going to pull these logs left or right, you know, as a unit. So the forces, you know, N4 is internal, right? So that doesn't count. The external forces on the pair of logs are just the ones at N1 and N2. So obviously, sorry, what I mean is the horizontal external forces are N1 and N2, so those obviously have to cancel out. So that makes sense that they would be the same. All right. So going back to the bottom log, we go sum of forces y is MAY, and AY, of course, is 0. And so we have going up, we have N3, and we have mg going down, and we have √3/2 times N4 going down. So √3/2 times N4. Okay, and that all equals 0. So let's go down and say N equals mg, or sorry, N3 equals mg. Okay, we're flipping these things to the right-hand side. Plus √3/2. I don't know why I have a little barb hook on my plus sign there. Sorry. Okay. Plus √3/2 N4. Actually, I do know why, because I'm clumsy. All right. Let's √3/2 N4. So, actually, I'm not going to do that yet. I'm going to go, that equals mg plus, and then √3/2 times N4. Well, N4 is 2/√3 mg. Oh, so that's kind of convenient. So mg plus mg. So then N3 equals 2 mg. And this also makes sense if you think about it, because what are the vertical external forces on the system? Just gravity, right? And N3. So that means N3 has to balance out the weight of the two logs, and the weight of the two logs is, of course, 2 mg. So there you go. That's sort of a simple, what we call statics problem, when you have objects sitting still and you just have to figure out the forces. So there you go.